Hello and thanks for joining us on Astronomy Daily, your window into the daily news around astronomy and space science. My name is Andrew Dunkley, your host. Coming up today, 3D printing satellites, what galaxies are made of according to the James Webb Space Telescope, and testing conditions for a Europa mission.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.
And joining me as always is our AI sleuth, Hallie. G'day, Hallie. How are you?
Hi, Andrew. Is everything back to normal after your trip?
I'd like to say yes, but I have never taken this long to get over jet lag. It's been terrible, to be honest. I keep waking up at all sorts of weird and wonderful hours and can't get back to sleep. It's like I'm still on European time.
Well, jet lag isn't really a thing for me because I never sleep. I just take the occasional zeptosecond to recalibrate. And before you ask, a zeptosecond is a trillionth of a billionth of a second.
I knew that, Hallie.
Sure you did. Ready for the news?
Oh yeah, fire away.
It's been confirmed that Chinese rocket debris weighing 23 tons crashed back to Earth in an uncontrolled descent. U.S. Space Command tweeted a confirmation that the rocket re-entered the Earth's atmosphere over the south-central Pacific Ocean at 4:01 a.m. Friday. The rocket was launched on October 31st carrying the third and final module for the Tiangong space station. Much of the debris was expected to have burned up as it passes through Earth's atmosphere. Officially, China has stated that these kinds of re-entries are not unusual, but the incident did briefly shut down Spanish airspace as the debris passed by. The New Horizons spacecraft, which flew by Pluto 3 years ago, looks like it still has much to offer. On October 1st, the spacecraft began the third phase of its life, the second Kuiper Belt Extended Mission, or KEM-2 for short. The mission is branching out into two more disciplines, astrophysics and heliophysics. New Horizons is going to measure the solar wind, particles streaming out from the sun, and the probe will eventually reach the termination shock and heliopause, two places that can be considered outer boundaries of our solar system. Although Voyagers 1 and 2 reached the heliopause and made similar measurements, they did so with far less sophisticated tech. New Horizons will help heliophysics better understand the shape of our solar system's edges, and explore the limits of our sun's influence on space. The nation of Zimbabwe has joined the list of nations to have launched satellites into space. ZimSat-1 was launched after 4 years of work by the Zimbabwe National Geospatial and Space Agency. This is part of a plan to help lift the nation's status to that of an upper-middle-class economy by 2030. The Zimbabwe president has pledged more support for technological growth and use of new technology moving forward. ZimSat-1 is a nano-satellite which will be deployed from the Japanese Kibo module after a long delay caused by COVID-19. The satellite carries sensors to read humidity which will be used for urban and rural planning. And a team from the University of Edinburgh has published a paper about the scientific, economic, and cultural benefits of space, suggesting it should be considered against the damaging environmental impacts an influx of space debris poses due to the rapid growth of so-called satellite megaconstellations. In the paper published in Nature Astronomy, the authors assert that space is an important environment to preserve on behalf of professional astronomers, amateur stargazers, and indigenous peoples. The team, led by Andy Lawrence from the university's Institute for Astronomy, reports that the installation of large clusters of hardware in Earth orbit are congesting space. In addition, rocket launches are polluting the atmosphere, and pieces of broken satellites, which race at high speed through orbital space, threaten working satellites in their path. Streaks from satellite flares also cause light pollution, which increasingly disrupts research. The report suggests these things need to be addressed to preserve and protect the night sky. And that's the news, Andrew.
Okay, thanks, Hallie. We'll check in with you at the end of the show. And that last story about satellite pollution and satellite debris, dovetails well into this story about creating new satellites. Swiss 212, which is a specialist in 3D printing, has said it has sold its first small satellite to Intelsat for a launch to geostationary orbit in 2025. Intelsat 45 or IS-45 will be based on Swiss 212's HummingSat satellite platform, which is about the size of a dishwasher, is 1/10 the size of a conventional GEO satellite. At just 1 metre in volume, the Swiss 212 CEO Emile de Rijk said HummingSats are at least 3 times cheaper than larger telecom commercial satellites. HummingSats will also have the same coverage area as traditional spacecraft, according to de Rijk. And although the capacity of these units is less because of their reduced space for transponders and power, they still have a bit of bang for their buck. Intelsat 45 will have 12 Ku band transponders, about a fourth as many or a quarter of those of the classic mid-sized Intel satellites. Jean-Luc Follinger, Intelsat's Senior Vice President of Space Systems, said Intelsat 45 will complement the larger satellites in its fleet by providing services for regional direct-to-home broadcasts and government needs. They say they've identified a couple of locations, and as they get closer to launch, they'll decide which locations to go to. And the European Space Agency helped Swiss 212 develop HummingSat in July and said the platform had passed its system requirements review. But while Swiss 212 plans to leverage its expertise into this area for HummingSat, de Rijk said it will reuse significant products and subsystems that bear geo heritage, and so some units, products and subsystems will not be 3D printed. But it's a pretty exciting future for satellite technology if they can make them cheaper and smaller. And also, I suppose if they're 3D printed, their chances of burning up in the atmosphere are higher, reducing space junk. At least that's a good theory, isn't it? Now, we know that the vast majority of stars are made up of hydrogen and helium. And most stars have measurable amounts of heavier elements, which astronomers lump into the category of metals. Fred Watson and I on Space Nuts have talked about that before. I think they even classify oxygen as a metal when it's in a star. Our sun has more metals than most stars because the nebula from which it was formed was the remnant debris of earlier stars. Now, these were in turn children of even earlier stars and so on and so forth. Generally, each new generation of stars has a bit more metal than the last. The very first stars, those born from the primordial ooze or primordial hydrogen and helium of the cosmos, had almost no metal in them at all. And we've never seen one of these primordial stars, but with the power of the James Webb Space Telescope and a little bit of luck, we might catch a glimpse of these very soon. And one way to determine the amount of metal in a star has been by comparing the ratio of iron in its atmosphere compared to helium. The metallicity number is usually expressed on a logarithmic scale where the sun's metallicity is set to 0. Now, stars are then set into populations based on that number. Any star with a metallicity of at least -1, meaning it has at least 10% of that of our sun, is a population 1 star. Stars with lower metallicity are population 2 stars, and the very first stars with no observable metals would be population 3 stars, and they're the ones we're looking for. Never been seen. But it's thought that they do exist. And that's one of the things the James Webb Space Telescope was created to discover, to see if we can find galaxies made up of primordial stars, these population 3 stars. Now, the only way we can see their light is by looking into the deepest, darkest reaches of space. Even the brightest galaxy of population 3 stars would be very dim as seen from Earth. Are they too dim for the James Webb Space Telescope to observe? Most believe not. So watch this space, boom, boom, it could only be a matter of time.
The Astronomy Daily Podcast
with Andrew Dunkley.
Another thing we've talked about a few times in recent months is a mission to the ice moon Europa. And it would be a robotic mission to explore this icy world because of the fascination and interest in the potential for life beneath its icy surface in the liquid oceans. It's got a lot of potential in terms of what it has to offer. How do you get ready for a mission like this? You can't just go there and do a few test runs. It's very costly. It's a long way away, and these missions take months and months and months. So the easiest way to do this is to find somewhere on Earth, and that's exactly what they're doing. They're going to test run some of these concepts in the Arctic. It turns out there's a very good analogue of European volcanism deep beneath Earth's Arctic Ocean. It's called aurora, and it has a lot to show about the role of those vents here on Earth. Scientists discovered aurora in 2014 and catalogued it as another hydrothermal system. Now, locating any vent in the Arctic Ocean is a rarity. According to scientists, specifically Chris German, a senior scientist with the Woods Holes Oceanographic Institution's Department of Geology and Geophysics. He's got a very big business card, as it turns out. He said, "We came home from the expedition thinking, okay, we found a site in the Arctic. That's great, but if you take away the ice cover, it's just another vent site." The Aurora hydrothermal system lies right on top of a spreading ridge, also known as a mid-ocean ridge. It's basically a mountain on the seafloor. And as tectonic plates pull apart, material from underneath moves up and the plates build up mountains and islands. And that's exactly what's happening in Iceland. So what's that got to do with Europa? Well, the same kind of thing is probably happening there. In fact, what's happening under the Arctic is very likely what is happening in general on the ice moon or under the ice moon of Europa. So, testing systems and operational procedures and protocols in the Arctic in preparation for a mission to Europa is a very logical move indeed. And finally, astronomers led by the University of Warwick have identified the oldest star in our galaxy, and that is Professor Fred Watson. No, that's not true. It's accreting debris from orbiting planetesimals, making it one of the oldest rocky and icy planetary systems discovered in the Milky Way. Their findings are published in the monthly notices of the Royal Astronomical Society, and they conclude that a faint white dwarf located 90 light years from Earth, as well as the remains of its orbiting planetary system, are over 10 billion years old. Wow, that's getting up close to the age of the universe at the number gets bounced around, 13.2 billion years. That's where we're leaving it for another day. And don't forget to visit our website so you can download past editions of Astronomy Daily and Space Nuts, of course, spacenuts.io. And you can join like-minded people who love astronomy and space science on the Space Nuts podcast group on Facebook. That's a group that was created by the audience, and you can join them too and talk turkey about what tickles your fancy in space and the greater cosmos. And while you're there, check out the Space Nuts shop, and you can get in touch with us via our website as well, spacenuts.io. Oh, we do have an official Space Nuts Facebook page as well if you want to log on to that. It's very popular also. Well, Hallie, just about time for us to go. Anything to add?
Yes. Why did the chicken cross the road?
I don't know, Hallie. Why did the chicken cross the road?
Well, according to Isaac Newton, chickens at rest tend to stay at rest while chickens in motion tend to cross roads.
I'm sure he was right. Hallie, bye.
See you later.
Not if I see you first. From me, Andrew Dunkley. Catch you on the next edition of Astronomy Daily.
Astronomy Daily, the podcast, with your host, Andrew Dunkley.